What do you see here? Maybe you noticed that the distance between the car in front and the car behind isn't changing. Or maybe you noticed that the driver's hands aren't on the steering wheel. This free-flowing traffic situation and the pleasant or stress-free driving experience is enabled by infrastructure. The infrastructure enables travellers to move more predictably between points A and B in both comfort and in safety. It also enables better traffic flow at the aggregate level so that the road or toll operator can achieve higher overall throughput, which has the effect of raising toll revenues. When cars and infrastructure speak to one another, traffic flows and densities can be better managed to alleviate traffic congestion. Similarly, those traffic flows can be orchestrated to reduce emissions of various types. And last but not least, accident rates can be reduced.
In this catalyst, we worked across the wider ecosystem and we leveraged our existing relationships with vehicle OEMs, standards organisations and universities. One of the key stakeholders was that of the toll road operator. And here we have Autostrada del Brennero, who own and manage one of the most important waterways in Italy, the A22. They give us a focal point really for the problem statements that we tackled in the catalyst. Together with our other champions of IAMTS, which is an international alliance for mobility testing and standardization, and Imperial College London, a global top 10 university who provided expertise in the area of smart mobility. Our other champions, Telecom Italia, Orange, Sparkle and British Telecom, worked very closely with all of the participating vendors, Huawei, Tioco, Incognito and Netcracker, to build an overall solution for intent-driven autonomous networks.
So our first scenario focuses on a coordinated driving use case as specified by 5GAA. The coordinated driving here is being done via speed advice. The toll road operator collects, using V2X, telemetry from the road and derives an overall situation aware. The customer benefits centre on safely reducing traffic congestion and increasing toll road revenues. While it's still under discussion, the expected CSP value capture mechanism here would be outcome-based pricing, where both risks and value would be shared. That is, if the outcomes are met or exceeded, the CSP revenue is higher, while if the outcomes are not met or not all met, then the CSP revenue would be lower. Tires are a major source of pollution. When the wheel comes into contact with the road surface, rubber is erased. These erasures or emissions are microplastics. As vehicles brake, accelerate and turn, small amounts of these microplastics are emitted. These are absorbed into our air, our water and our food supplies. This problem is set to get worse, not better. And the reason why is somewhat paradoxically because of electric vehicles. EVs weigh much more and typically exhibit much higher torques at lower speeds, and the result of which is their tyre emissions tend to be much higher than comparable internal combustion engine based vehicles. So tyre emission amounts will vary according to a number of factors. For example, the ambient driving conditions, so both temperature and the type of road surface, so whether it's asphalt, concrete, pavement, or gravel, for example, all of these things will have a different impact. The conditions of the vehicle, so what's the weight of the vehicle, what is the tyre pressure in each of the tyres of the vehicle, and lastly the driving style, so speed, acceleration and braking, all of these things are factors. So the key idea then is to modulate the wheel torque to reduce the forces between tyre and road without significantly affecting the overall vehicle operation. So based on telemetry covering all of the mentioned factors which are collected from the road, the vehicles and HD maps, municipalities can in real time predict propensity for higher emissions and instruct the vehicles to modulate the torque in time. This instruction is reliant on low latency connectivity, which can be delivered via V2X services. So as mentioned, we will use V2X to modulate the vehicle torque where that's possible, but V2X capable vehicles are not widely prevalent yet. So within the catalyst, we're also looking at other compliance type mechanisms that we could use, which brings us to social contract. So a social contract simply is an implicit agreement between the members of a society to cooperate for the social benefit of everyone. So within the catalyst, we make use of digital ledger technology as a means to enforce the social contract, essentially orchestrating the behavior or driving style of the agents in a smart city environment. So citizens' tokens would be debited or credited according to their good or bad driving behavior, as the case may be. There are many stakeholders for pollution reduction: municipalities, road operators, vehicle OEMs, and even the tyre manufacturers. All have public environmental, social and governance targets that contribute to national and global sustainability goals. These ESG goals are not simply aspirational, there's a real cost association here. If the goals aren't met, the cost of capital to the business, that is, the rate at which they can borrow money via the bond markets, will increase. So if pollution increases, the cost of capital will go up, and therefore the CSP revenue should go down under an outcome-based pricing model. Similarly, if pollution decreases, the bond rates will decrease, and thus the CSP should benefit more.
Let's find out more how intent and autonomous networks actually helps for these two use cases. CSP is critical to enabling the toll road operator solutions for the benefit of the road users. Each role is important, and each have their own specific requirements or needs. Let's take a look at some of those individual needs. Road users, they want to be able to travel from A to B as quickly and as safely as possible. For the toll road operators, they want to optimize a few key KPIs: traffic speed, flow, density, and at the same time maximizing the revenue within the safety constraint. And CSPs, they need to provide the right connectivity where it's needed, and also to be able to provide dynamic and scalable services based on the actual road conditions that are happening in real time. So all these wants and needs, this is what we call intent. But it's what you want, not how to do it. That's the key difference with intent. The system can only adapt to all the different needs if it actually knows them. So it's very important that we capture them in a formal language. So intents are the wants, the requirements, the goals, or the constraints. To understand better, let's take a simple example. Here the toll road operator's objectives are stated in a very terse and formal language, which is then parsed to form an overall intent expression. Here that expression is shown more generally, where the stated objective can be parsed into constituent parts that form the overall intent expression. Intent itself needs to work within an overall framework, and this is where the TM Forum's autonomous network framework comes into the picture. The autonomous network framework is a domain agnostic and vendor agnostic framework for autonomous operations, broken into 3 different operational layers. Within those layers, they realize different capabilities using closed loops. And as you can see, they break down across business, service, and resource categories. Gluing all of this together is the concept of the intent: business intent, service intent, and resource intent. Here the framework is applied for our catalyst. As you can see, the particular needs at the top for the different stakeholders, and the fact that we're using different technology domains to provide the overall connectivity for V2X. The framework allows us to capture all the needs stated as intents. The network domains provide self-ex capabilities such as auto-scaling, to name just one. And overall, the approach using the sliders allows us to optimize multiple KPIs so that all needs can be balanced throughout the framework. The framework also helps us to build the solution block by block using the autonomous domain. So the intent API is a crucial part of realizing the domain, and the development and design of the intent API is a major technical focus for this catalyst this year. So on the intent API, we need to first and foremost realize that it is an interaction. It is a dialogue. It is a dialogue between two different parties. And the dialogue really turns into more of a conversation because there's multiple back and forth statements, offers, counter offers, if you like, between the two parties. All of this is really a negotiation. Communication, negotiation, talking to each other is crucial to developing the understanding between the vehicles and the infrastructure. That's what enables the use cases of speed control and torque control. There are several benefits to this catalyst. Number one, we want to simplify the ordering of the V2X services, and we want to provide elements of zero-touch provisioning to realize those services. We want the autonomous domains on the network side to be self-healing and to be self-optimizing. Also, we want an overall closed loop, which includes the orchestration and assurance of those services. The bigger picture is that all of autonomous networks is really about the optimization of efficiency, but also these higher value services. And to do that, we need new revenue models, such as the distributed outcome-based pricing, and also some other value-added services in the ecosystem to fully exploit the CSP value. Overall, the global picture on V2X and smart mobility is around fewer accidents, less emissions, less congestions, and to do that, we need intent-driven autonomous networks as part of the solution. When we understand the roles and the needs of the different stakeholders, we can then examine the real value we bring as CSPs in the ecosystem. If we take these key roles within the ecosystem and look at how they all interwork with intent-driven autonomous networks, we believe we can create an overall solution that creates value, which positions the CSPs as key enablers of this type of innovation. Smart mobility is about connectivity and infrastructure. If that connectivity and infrastructure is more intelligent, more self-governing, more understanding of the real needs, we believe that the CSPs can create and maximize the overall value in a very important smart mobility space that's driving for increased sustainability for the benefit of all road users.